This video is part of a lecture for multivariable course, and I'm gonna solve one examples of Lagrange multiplier method and find points that are closest to the origin on the hyperbola xy equals to 3 using Lagrange multiplier. So let me start. Basically, I want to minimize the distance d, and first let me actually graph it for you. So this is x-axis, this is y-axis. Then I have this graph, which is y equals to 3 over x, and then if I pick this point x and y, it has the closest distance to the origin, and based on the symmetry I also have this point. So at the end of the day I'm gonna find 2 points that are closest to the origin. And so I need to minimize the distance from the point xy to the origin, and if you remember the distance formula, it would be x minus 0 square plus y minus 0 square. Okay, so now instead of minimizing this function, if I minimize the inside function and then I take a square root, basically I minimize the whole function. So all I need to minimize is to d squared. Just for the simplification, I just look at the inside function and I minimize that. So I'm gonna minimize the function f, which is x squared plus y squared, subject to the constraint what? Subject to the constraint is g of xy, which is basically xy equals to 3. Okay, so I'm gonna use the Lagrange multiplier method for that. And for the Lagrange multiplier, I need to solve this system of equation. Gradient of f is equal to the lambda gradient of the constraint, and the constraint equals to c. Okay, so what is gradient of f? Gradient of f is partial derivative of f with respect to x, which is 2x. Partial derivative of f with respect to y is 2y. Let me just move this one a little bit down, and then it's lambda gradient of g, derivative of that with respect to x, derivative of that with respect to y, and also g equals to c. So let me write the system of equation that I need to solve. The first coordinates are equal to each other, so 2x is lambda y, and then 2y is lambda x, 2y is lambda x, and then g equals to c, it would be xy equals to 3. I need to solve this system of equation. I have 3 equations. I'm gonna start with the first one. 1, 2, 3. For the first one, x is equal to lambda y over 2. Then I'm gonna plug in that one into the equation 2, so I get 2y equals to lambda, and then instead of x I'm gonna write lambda y over 2. Okay, so I get what? I get 4y. Let me do the cross multiplication by just giving this part a denominator 1, so I have 4y equals to lambda square y. Bring everything in one side and factor out the y. 4 minus lambda square equals to 0. So I get what? I get y equals to 0, or lambda equals to plus minus 2. Okay, y equals to 0 is not acceptable because it is not on our constraint. So Our constraint is our third equation. If y is equal to 0, I get 0 equal to 3, which is not good, so I don't have this one. So lambda equals to plus minus 2. Let's say if lambda equals to 2, then looking at the first equation, when lambda is equal to 2, I get 2x equals to 2y, which means that x is equal to y. Now plugging x equals to y into the third equation, I get x squared equals to 3, which is x is equal to plus minus root 3. So x is also equals to y, so I got these points. Root 3, y equals to root 3, and then negative root 3, negative root 3. Okay, this is one a set of 2 points in here. And also, what happens if lambda is equal to negative 2? When y is negative 2 on the first equation, I get x equals to negative y. Plugging into the third equation, I get negative x squared equals to 3, which is not acceptable. Okay, therefore lambda cannot be equal to negative 2, so the only points that I got, there are these points. So let me put f, find the distance, root 3, which is, what was the function f? It was x squared plus y squared, so this is 6, and so the distance would be square root of 6. We're going to do the same for negative root 3 and negative root 3. This is also 6, and the is also root 6 for both of them. So the points that we are looking for is negative root 3, and root 3 and root